Hi, this is Eric White. This is the next screencast in this ongoing series of screencasts on writing recursive pure functional transforms of XML. And in this screencast, we're going to examine this interesting question, which is, why do these transform methods return object? And in a nutshell, the answer to this question is sometimes in these transform methods, we want to return a single object. We might want to return a single X element or even a single X node, or we might want to return a collection of objects, a collection of X elements or a collection of X node. And we're going to be replacing a single element or a single node with a collection in our transform. A concrete example of this is that let's say that we're looking for a content control that exists at the paragraph level, in other words, a block level content control, and we want to replace this content control with multiple paragraphs. Let's go and look at this example and write this transform. Here I've set up my little shell OpenXML program. I've already added my references to my assemblies. I've added the references to document format.openxml and also the reference to the Windows base assembly. And I have added my various using statements that I want to have around. I want to have this using for system.xml.link, the using for the OpenXML SDK, and the using for OpenXML Power Tools. I've added the ptutil.cs and pt-openxml-util.cs to this project. So we're all ready to go here. All except for I'm going to remove this namespace. I don't need that there. This is just an example program. Namespace is not required. Now let's go create our example document that we're going to transform. I'll go to the bin debug directory and I'm going to create a new Word document, call it test. And I'm going to insert 2 paragraphs, each with 1 sentence in them. And then between these 2 paragraphs, I'm going to insert a content control. Before I can add a content control, I've got to turn that on in the ribbon. So I come over here to customize ribbon and I want to turn on this developer tab in the ribbon. So then I click OK and now I've got a developer tab. Now let's go over to the developer tab and I'm going to I'll add a plain old content control. I don't need a rich text content control. And I'm going to pull up the properties for this. I'll call this replace me. So now we've got a content control in there. It doesn't really have anything in there. I'll put a single space in there so it looks a little better. One thing that we can do is we can put Word into design mode. And when we put Word into design mode, it changes the appearance of the content controls to these little kind of open and close symbols. And it has the tag in this content control. So now our goal is to write a transform that looks for this particular content control with this tag and replaces it with 3 paragraphs. So we're going to be replacing a single element with 3 elements. Just to make it easy on ourselves, I'm going to drag test.docx so that I can look at it in Visual Studio. Here's our content control, this SDT element, and in that content control, we can see that there's an SDT-PR element that is the content control properties, and underneath there's a alias and a tag. The alias being the title and the tag being the tag. So let's write our transform. Let's do our usual thing. We'll open it for read-write by passing in true to the open method. Now we're casting this to X element because we're going to write a transform method that returns object. Now we'll replace the root in xdoc. And we'll put that X document back into the main document part. Now let's generate our method stub. Let's change this to object and change this to X node. And let's write our boilerplate identity transform. Now we've written our identity transform. Now we're going to add our new rule into this transform, looking for that content control that has a tag of replace me. So we're going to say if element.name is equal to w.sdt and element dot, let's see, it's going to be a child element named tag and with a value of replace me. So if element.element we're using that interesting idiom that we talked about several screencasts ago, where you use the extension methods to write code that can't fail. So here's code that cannot fail. So we have this element with the name of w.std. We know that at this point in time. So then we call the element's name passing w.tag to that, and that's going to return either a collection of one element or a collection of 0 elements. And then we call the attributes extension method, passing in the name w.val, and that's going to return either a collection of one attribute or a collection of 0 attributes. Then we call first or default, and if the collection is empty, then that returns null, and if the collection is not empty, then it returns the attribute. And then we cast that to a string. And when we cast that to a string, if it's null, null casted to a string is still null, and the attribute casted to a string is the value of the attribute. And then we can test that against replace me, and null compared to replace me returns false. And if we do have an attribute and the attribute does have the value of replace me, then this will all return true. So we've now written our rule for looking for that content control. And if we find that content control, then what we want to do is we want to replace that content control with 3 paragraphs. So now in Link and in .NET, when you want to new up a collection right in line, the easiest way to new up such a collection is to initialize an array. There are lots of other ways. You could create a list, or you could create a hash table. You can do anything, but the simplest and shortest syntax for newing up a collection is to create a little initialized array. So I'm going to say var replacement content is equal to new. And I'm going to use the array initialization syntax. And here I'm going to put a new X element, and I'm going to put a w.p. So we've got our paragraph, new X element, W dot R. So now we've got a run. W dot T, and there we have our text element. And so now we've newed up our first replacement paragraph. And let's add two more. One of the things that I like about the syntax of .NET and the syntax of array initialization is that I'm allowed to leave this final trailing comma here. That's perfectly valid syntax. It just eases my editing process if later on I want to come back in and add a fourth paragraph. So I think we're done. No, we're not quite done. We've newed up our replacement content, and now we have to return it. Replacement content, the type of it is actually an array of X element, and just so that we can prove that that is the case, we can explicitly declare that. So now it's an array of X element. I can see one little bug that I've written into this program. Up here, before I get the elements of w.tag, I have to call element of and pass in w.sdtpr. So looking at our main document part, we've found that we're in here. We know we have an SDT. We then get the elements of SDTPR, and that returns a collection of this element. And then we get elements of w.tag, and that returns a collection of this element. And then we can get the attributes w.val, and that returns a collection that contains a single attribute, this w.val attribute. So let's run our example and see how that works. It runs very quickly, of course. And so now if we look at our new document, we can see, in fact, that that content control is gone, and it's been replaced with this paragraph run and text node string here. It's got 3 paragraphs here. If I format the XML, we can see it in an easier way. And if I open up test.docx, we can see, in fact, it does have the content that we expect it to. So the question would be, what if this method did not return object? Well, if you look at the various places where we are returning values in this method, right here we're returning an X element, down here we are returning an X node, and up here we're returning an array of X element. And there is no type that we can put here that encompasses all of those 3 types except for object. There are languages that have much fancier type systems than C#, and in those languages you can actually declare a type that encompasses either a single X element or a collection of X elements or a node or so on. There's an interesting story. There was an experiment done once I saw with languages where they made a much more elaborate type system, and what happened is about 80% of the developers found it was too cumbersome to use, too cumbersome to learn. As it turns out, C#, I think, hits kind of the sweet spot in a type system where you can have strongly typed collections using generics, and you can declare all of your various types, but you can't declare a single type that encompasses either an array of X element or an X element or a node. We could have a whole different type that kind of encompassed all of that, but it would be effectively the same thing. We wouldn't get any stronger typing than what we have right here. So in assessing this situation and contemplating how to write these types of transforms, I determined that it's just better to make these transforms return object. And that means that up here where we actually call the transform method, we always end up casting to X element to get the value out of the transform. There are times when you could actually write this to return just an X object or an X element or an X node. That certainly is possible, but I found it's just simpler to make these transform methods return object. One good point about this is that later on, when I'm going back and looking at code that I wrote several years ago, and I see this particular pattern where I have a static method that returns object and it takes an X node, and it might take further parameters in there also, it clues me in, oh, this is a recursive pure functional transform. And I look at it and I see, okay, there's my identity transform. Up here is my transform. There's a rule there. The rule is looking for a content control. It's looking for a content control with a particular tag with a value of replace me. It gets to where you can read these transforms in a fairly natural way. Now, this requires that you become familiar with all the idioms that we use in these types of transforms. But, however, once you learn all of this stuff, it becomes easy to read this type of code. That's all I'm going to cover in this screencast. You can find me on my website at ericwhite.com. You can follow me on Twitter at ericwhitedev, and you can follow OpenXML on Twitter at OpenXMLDev. Thanks for watching.